Assalamualaikum warahmatullahi taala wabarakatuh. My name is Nur Ismailida binti Ismun and my partner is Nadia Zulaikha binti Ishaq. So today we are gonna explain our first assignment, which is Electrical Basics in Marine Electrical Code of Practice, lectured by Mr. Asrulizam bin Abu. So I'm gonna explain about introduction. The first one is alternating current. Alternating current describes the flow of charge that change direction predictably. It is used to deliver power to houses, office buildings, air transportation, sea transportation, and many appliances need an AC system. An alternating current is a wave phenomenon. It shares many of the properties to other wave phenomena such as sound. Few points to be noted about power on board. Three-phase power is preferred over DC as it gives more power for the same size. Three-phase are preferred over single-phase as it draws more power, and in the event of failure of one phase, other two can still work. So the other one is direct current, which is DC. Direct current is defined as the unidirectional flow of current which flow in one direction. Voltage and current can vary over time so long as the direction of flow does not change. In reality, a battery will slowly lose its charge, meaning that the voltage will drop as the battery is used. So beginning from the mid-20th century, rapid development of modern power electronics is today paving the road to DC ship power system for the following reasons. The first one is improvement of prime mover efficiency and reduction of fuel cost, weight and space saving, generators operating with a unity power factor, lower transmission losses, faster and simpler parallel connection of generator, simpler implementation of energy storage. So, the objective in basic electrical basic is to understand the two basic concepts of AC and DC system used in marine environment. The second one, to enhance electrical basic in the system operated and regulation related to the code of practice in marine environment.
Okay, voltage on board ship, which firstly high voltage. High voltage is mostly used on the big and large vessel or ship. High voltage is used because the high power requirement on board of the ship, which use a lot of machineries, equipment, and then large electrical demand. So a high voltage is required in order to reduce the machinery size and reduce space on board, which is related to the Ohm's law. The higher the voltage, the lower the current, which help in reducing the machinery size and reduce the space on board, which can also reduce the weight, so the ship will be more lighter. So next is to reduce cost as the machinery size is reduced, and then for high voltage it is usually more than 1 kilovolt, which is 3.3 kilovolt and 11 kilovolt. For low voltage system is the supply needed was less than 1,000 volts. This system is rarely used on board, but small boats use the system. As there are less machinery used on the board, the system is not complex as the bigger ship. Okay, the reason why the low voltage is not used popularly nowadays because if a large load is connected to the whole system, the magnitude of the current flow becomes too large, resulting it overheating due to high iron and copper losses. Okay, next we move on to current on board ship. Okay, there is two current, which is AC and DC. AC is alternating current. Alternating current is a form of electricity that alternate in direction at a frequency defined by the generator, usually 50 or 60 Hz. This current is popular on the early days because of two major factors that give advantage, which is it can easily be stepped up and stepped down and can easily be interrupted. Then the direct current. There is many equipment on board that needed AC, such as motor, engine, generators, cooling system, and others. AC power is the same as that found in the industry and the household. Power conversion equipment is used to convert power from one to another. Okay, direct current. Direct current on board usually produced by solar system which demanded by the DC equipment. The solar system were connected to the battery and act as a battery charger which the battery stored and supplied to the DC equipment or DC system if needed. DC power is a low voltage form of power that directly compatible with the battery system. So there is a battery bank that store the energy and will deliver the energy to the system if needed. For power requirement estimation on board a ship, there is a step of estimation such as first step is calculate the resistance of a ship, decide on the type of the ship propulsion system, estimate the engine or diesel alternator rating. Okay, this is the important step in ship design process because ship power is a deciding factor for many other aspects of the industry, such that a ship with more power requirement will automatically require a large amount of fuel. That is the reason why we need to calculate all the loads and the power requirement first. Okay, so this is the example of propulsion system, which is the basic component used in the diesel electric propulsion system. Okay. Okay, this is a load chart. Load chart is required where all the electrical loads were listed, considering the three operating conditions in general, which is sailing, harbor, and maneuvering. Okay. In the load chart, the power requirement of each electrical load on the ship is calculated by multiplying the maximum rated power of the component with two factors, which is load factor and utility factor. So all this is very important to calculate all the power. So after that, we can decide whether we are going to use what system. So the calculation is very important. Okay, the figure show electrical system on board the ship, which is a summary of the electrical system. Okay, we have DC power source, DC power distribution, AC power source, AC power distribution. Okay, this is basically the block diagram shows the functional component of an electrical system of a cruising vessels. The system is equipped with house and starter batteries, AC generator, solar, and then inverter charger, and then engine charging and others. Okay. DC and AC power source provide the energy to run the ship or a vessels, which the battery provide an energy buffer to supply power when there is not enough instant power available from AC and DC source. A power distribution network connect the power source, this is the power source, to the power consumer, which is this. This is the power source. And then this is the distributor that will distribute to the consumer. The electrical system design will require an understanding of the electrical consumer on the vessel, that is equipment and appliance, and the purpose of the deploy of the vessels. Okay. The equipment setup. Usually, the equipment setup is influenced by the project design objective, which in turn drive the cost of implementation. The design objective is such as before we design a vessel, we need to consider a safe implementation that meets relevant equipment and installation standard. Deployment of STAR offset solar and wind energy to reduce engine runtime, selection of battery capacity and technology, and then all the appropriate system monitoring and control. Okay, that's all. Okay, we move on to discussion. Okay, as we all know, mostly the high voltage is chosen about the shape because of a lot of criteria. So the measure is the difference of high voltage supply and low voltage supply, which on board there is a complex networks and connection. So that is why the high voltage is required. So high voltage systems are usually at neutral and use current limiting resistor to prevent such faults. So to prevent such faults such as the short circuit and others, it helps by the high voltage system. Okay. There is a lot of advantage from the high voltage system, and there is also the cons, which is this advantage of the high voltage system. So the advantage is the help in reduction in size of generator, motors, and cable, which the space or weight can also be saved by the lower current. As the higher voltage, the lower the current. Refer to the Ohm's law. Next, high voltage resulting the ease of installation, cost reduction, lower losses, and the utilization of generated power can also be more efficient. Lastly, it helps in reduction in short circuit level in the system, which decide the design and application of the electrical equipment. Okay, next disadvantage of high voltage system is it needed the higher insulation for cables and equipment needed. Okay, and it also can cause higher risk of electrical shock and hazard of arcing. Okay. We all know both AC and DC power that use in onboard the ship required in various type of equipment. A complex system will have separate housing and starting battery bank with sophisticated AC and DC power. The electrical system depends on the estimation of power requirement. As stated before, we need to calculate all the loads required on the board.
Thank you, Nadia Zulaika. In conclusion, students be able to understand the two basic concepts of AC and DC systems used in marine environment with the knowledge required to be applied in the mind of marine electrical electronics student. In addition, students also be able to improve the electrical basis of the operated and regulated system associated with the code of practice in marine environment with the search of as much information as needed to understand electrical basic. Thank you.